Hello everyone, this is Mr. Supnil Babasaheb Herwade, the lecturer in Mechanical Engineering Department, Sri Institute of Technology, Polytechnic Edra, Vichalkaranji. I am here with the next lecture on the third chapter, that is cast iron. In the first two chapters we have gone through the first chapter is of the crystal structure, so we can say the basic properties of materials. In that we have studied something about the crystal structure, unit cell, space lattice, and types of crystal structure like simple cubic, body centered, face centered, and hexagonal close packed structure. Then we have gone through the properties of materials like physical, mechanical, chemical, thermal properties. Then we have gone through the microscopes. Okay, and in second chapter we had gone through the ion carbon equilibrium diagram, the main point. Then what is meant by solid solutions, their types, then types of steels, okay, like plain carbon steel, alloy steel, spring steel, stainless steel, okay. And so these points we have covered in first two chapters. Then we will start with the third chapter, that is the name is as a cast iron, okay. As you know, the cast iron is a alloy of iron and carbon with a carbon ranging from or more than 2%, okay. Then the subtopics of lecture are like, the first point is introduction, second classification of cast iron on the basis of different things. Then we will go through the first four important cast irons that we have in the syllabus, that is grey cast iron, white cast iron, nodular cast iron, malleable cast iron, and last point will be of the specification of cast iron, okay. And in four of the cast iron we will see their composition, their properties, and their applications, okay. Next we will start with the introduction. See, cast iron is a basically alloy, same way as we have seen in the second chapter, is a steel is also alloy of iron and carbon. Same way here, cast iron is also alloy of iron and carbon. When we go through the iron carbon equilibrium diagram, we see the steel where the carbon ranges from 0.008% to 2%, and above 2% we have cast iron. So in cast iron the carbon ranges from 2% to 6.67%, but it is a theoretical one. The value from 2 to 6.67, it is a theoretical one, okay. When we use it in a practical, because 2% or 2.1% carbon in a cast iron is having somewhat softer cast iron, and when we think about the above 6% carbon, it will make it more harder, more brittle, and it cannot be used in a practical ways, okay. So the commercial cast iron which can be used in practicals, which have the composition of carbon from 2.3% to 3.75% carbon with other elements such as silicon, phosphorus, sulfur, manganese in a minute amount, because as cast iron is a ferrous metal, okay, so it have base as a iron. So iron ranges from 85 to 90%. Then we have the carbon from 2 to 6%, and then what remains 6 to 7% is all other elements, okay. So cast iron is a ferrous metal, okay. Next we can see the general properties of cast iron, like it is having a low cost means when we compare the cast iron with the steel is having the higher cost as compared to cast iron, okay. So cast iron is having the low cost, or it is a cheaper than steel, okay. Next, high compressive strength. When we compare the cast iron and steel, the steel having good tensile strength, but it is having some low compressive strength. But cast iron, as it is a rigid one, we can say it is having a high compressive strength, okay. Next, wear resistance is high for a cast iron. Then good machinability in grey cast iron. The grey cast iron is somewhat softer in all four cast irons. Simply in nature we found, or we can convert only two cast irons, that the grey cast iron and white cast iron in nature, okay. That grey cast iron is having some grey color, white cast iron having its own white color, okay. But in that also the grey cast iron is somewhat softer than white cast iron, okay. So it has some machinability. Next, poor ductility and malleability, as it is having more carbon percentage, it is more harder, so it is having poor ductility and poor malleability. Ductility means we cannot draw, ductility is nothing but we can draw out the wires, and malleability means we can draw out the plates or the sheets from a material, okay. Next, they cannot be forged, rolled, drawn, and pressed, okay. As they are having more carbon percentage, they are harder one, they are having more brittleness property. So if we rolled it, then have a tend to form a crack in it, and that crack will tend to failure. So we cannot roll it, drawn it, or we cannot press it. We can have only cast, because we form only cast from these type of materials, so they are called as a cast irons, okay. So the cast irons are generally they are used for casting purposes, so they are called as a cast irons. Okay, next, these are the general applications we can see in the first. This is, we can say, a frame which is a casted frame. Okay, then this is a pan which were used generally in household, and this is a one sculpture, we can say a structure which is also a casted one. Okay, so these are the general applications we can see in the day to day life. Okay, next, this is a broad classification of cast iron on the basis of three things. So on the first basis, on the basis of microstructure. Microstructure means it is a structure which is present on the surface of material which can be seen through the metallurgical microscope. Okay, so on the basis of that we can classify the cast iron in the six parts, like first is a gray cast iron, second white cast iron, third nodular cast iron, fourth malleable cast iron, fifth mottled cast iron, and sixth chilled cast iron. Okay, then then next B, on the basis of furnace used, we have four parts: cupola cast iron, air furnace cast iron, electric furnace cast iron, and duplex cast iron. Okay, and C, on the basis of carbon and purity, we have three parts again: low carbon low silicon cast iron, high carbon low sulfur cast iron, nickel alloy cast iron. Okay, so this is a broad classification of cast iron, but from this, for our syllabus we only have the four things, that is gray cast iron, white cast iron, nodular cast iron, and malleable cast iron. Okay, we will go through it, we will see its composition, we will see its properties, its own applications. Okay, next we will start with the first one, that is gray cast iron. Okay, so see, why it is called a gray cast iron? Because when it get fractured, it shows the gray color from it. Okay, so why it shows the gray color? Because due to carbon being in the form of graphite, because gray cast iron have graphite in it, carbon it is present in the form of graphite, so it shows the gray color. Remember it will be asked in the exam. Okay, it is produced in cupola furnace by refining the pig iron. It is produced in cupola furnace by refining pig iron. Okay, see, we have composition like carbon from 2.5 to 3.8%, silicon 1.1% to 2.8%, manganese 0.4 to 1%, phosphorus less than 0.15%, sulfur less than 0.1%, and iron, which is remaining, it will be from the 85 to 90%. Okay, next we have properties. It is easily casted and machined. As we know, all the cast iron are casted and it is machined after we get the cast. Okay, then lowest melting point than steels. As you know, as carbon increases, the the material becomes more harder. It also becomes more brittle. As it becomes brittle, it may tend to have a low melting point. Okay, so the gray cast iron have the lowest melting point than steel. Okay, next, high vibration damping capacity. It have the high vibration damping capacity because it have the good compressive strength. As we have the good compressive strength, it can compress the things, it can damp the vibrations which are coming from the other surfaces or other material which is in motion, so it can damp the vibrations. Okay, next, high resistance to wear. As it is a harder one, it can resist the wear. Okay, next, low tensile strength. Low tensile, as it is having good compressive strength, so it generally have a low tensile strength, we cannot stretch it. Okay, next, high compressive strength. As it is having high compressive strength, it have the good vibration damping capacity. Okay, in the diagram we can see a microstructure. Okay, this is a microstructure of gray cast iron, where we can see the graphite in black color and alpha ferrite in white color. Okay, then graphite is in black color having the needle like structure, and we can say the graphite is there on the ferrite matrix because ferrite percentage is more as compared to the graphite. Okay, so the gray cast iron is a combination of graphite and alpha ferrite. Okay, next we will see applications. These are the applications of gray cast iron. We can see the gray cast iron can be used for producing heavy duty machine tools. Heavy duty machine tools because they have the high compressive strength. Then bed, presses, high pressure hydraulic parts, the frame, gears, bushings, piston rings, the cams, crankshaft, cylinder block, cylinder head, the gear, cylinder, the base, bed, flywheel, cylinder liners, pistons, the brake wheel, gearboxes, pressure wall, coupling plate, etc. These are the examples. Means the grey cast iron are generally used in the industry. You can see some examples here in picture. This is the pressure wall. These are the bushings, the gear. This is brake blocks. This is cylinder block. Okay, so these are the examples of grey cast iron. Okay, next we will go through the white cast iron. The white color is due to the presence of cement adding. As in a grey cast iron, the grey color is due to presence of graphite, and here the white cast iron is having white color due to presence of cementite in it. Cementite, which was gone through it in a iron carbon equilibrium diagram, which is the hardest one. Okay, next it have the composition like carbon ranges from 3.2% to 3.6%, silicon from 0.4% to 1.1%, manganese from 0.1% to 0.4%, phosphorus from less than 0.3%, sulfur less than 0.2%, iron, which is remaining, it ranges from 85 to 90%. Okay, then properties we will have excellent abrasive wear resistance. Excellent abrasive wear resistance, because in the four of these cast irons, the white cast iron is the hardest one. It is having more Brinell hardness number, or it is the hardest one. So it is having excellent abrasive wear resistance. It is extremely hard. It is very difficult to machine. It is a harder one because it presents, it have the Fe3C in it. And cementite is the hardest phase in iron carbon equilibrium diagram. So the white cast iron is very difficult to machine. We can get only cast from it. Okay, then high tensile strength, then low compressive strength, because in grey cast iron we have high compressive strength, it can damp the vibration. Here we have the low compressive strength, it cannot damp the vibration. Okay, when we have some compressive force on the white cast iron, it may tend to give it some crack, and that crack may tend to have a failure. Okay, then machinability is low as it is a harder one. Okay, as it is a harder one, we have low machinability. We cannot machine it well. Okay, just we can have a simple holes in it, that much. Okay, next, hard and wear resistance. As it is a hard, it cannot get wear easily, so it is having hard and wear resistance. Okay, next we can see the microstructure. See in the diagram we can see this black color, that is Fe3C, that is a cementite, and here we have the perlite. Perlite is nothing but a combination of alpha ferrite with the cementite. Okay, so this is a combination of perlite plus cementite. Next we will see the applications. These are the applications of white cast iron. It can be used for liners in cement mixers. This is cement mixer. Okay, it can be used as used white cast iron. Okay, then ball mills. These are the ball mills, and then we have the drawing dies or the extrusion nozzles. These are the extrusion nozzles. Okay, so these are the applications of white cast iron: nozzle, ball mills, and the cement mixers. Okay, next we will go through the nodular and spheroidal ductile cast iron. Nodular or spheroidal or ductile cast iron. Okay, it is obtained from adding small amount of magnesium to molten grey cast iron. Means nodular cast iron can be get from grey cast iron by adding simply a magnesium into it. It is in the range of 0.1 to 0.8%. What it changes? In grey cast iron we saw the structure of this black color graphite is like a needle one. Okay, or a straight line we can say, and here we can see the spheroids, or we can see the circular shapes. We can have the circular shape. This is changed by the magnesium. Okay, see, nodular cast iron is obtained by adding small amount of magnesium 0.1 to 0.8% to the grey cast iron. Magnesium encourages the graphite to form spheroids or the nodules. Spheroids means something which is in a spherical shape. Okay, next we have common composition: carbon 3.2 to 4.2%, magnesium 0.1 to 0.8%, silicon 1 to 4%, nickel 0 to 3.5%, manganese 0.1 to 0.5%, and what remains is iron, because it is these are the ferrous materials. Okay, then we have the properties. It's having high castability. Every cast iron is used for the casting purpose only, so it is having high castability, high tensile strength also, because as we have added the magnesium, it improves the ductility of a material, it improves the malleability of material, so that it increases the tensile strength. Okay, next, high wear resistance. As it is a cast iron having higher percentage of carbon, it have the higher hardness and higher wear resistance. Okay, then high toughness. Toughness means it is the amount of energy absorbed before failure. Means before failure, this nodular cast iron can absorb so much of energy. Means it cannot fail at easy loading. Okay, at low load. It cannot fail at low load because it can absorb all this energy. Okay, so it is having high toughness. Then good weldability and machinability. We can do a welding operation on this nodular cast and it is having good machinability because we are added the magnesium. It increases the ductility and malleability so that it is a softer one, so that we can do the machinability. Okay, or we can do some machining operations on it, just like a drilling, boring, cauldron boring, chamfering, all these things, so that because it is a softer one as compared to the grey cast iron, white cast iron. Okay, so this is a microstructure of a nodular cast iron where you can see the graphite in a black color which is in a spherical shape because addition of magnesium, and here we see the white color, it is a alpha ferrite. So we can say the nodular is placed in a alpha ferrite matrix because the percentage of alpha ferrite is more and graphite is less. Okay, next, these are the applications of nodular cast iron. It is like the valves, pump bodies, the gears, crankshafts, piston, rolls for rolling mills, the tubes, door hinges, automotive engine crankshaft, heavy duty gears, military and railroad vehicles. These are the two examples you can see with the help of figure. This is differential housing and second is a crankshaft. Okay, these all are the casted products. Okay, next, malleable cast iron. See, these are produced by heating the white cast iron at temperature at about 870 degree Celsius for extended time period and then cooling at a low control rate. Means the malleable cast iron is formed from the white cast iron by heating the white cast iron up to some temperature, something about 870 degrees Celsius for some time, and then we can cool that heated white cast iron with a slow cooling rate or low cooling rate, or we can cool it in a air or we can cool it in a furnace, so that as we know, as the cooling rate is high, means cooling rate is as cooling rate is low, we can get a softer material, so we can cool the white cast iron in the furnace or in a steady air. Okay, next, the white cast iron loses carbon which forms into nodules of carbon with a ferrite matrix. Okay, see in the diagram we can see these black colors are the free carbons. Okay, and this white color is the free ferrite matrix. Okay, so we can say that free carbon are nothing but the nodules. Okay, and this is a white color, the ferrite matrix. Okay, so here we have the composition: carbon from 2 to 3%, silicon 0.6 to 1.3%, manganese from 0.2 to 0.6%, phosphorus less than 0.15%, sulfur less than 0.10%, and what is it remaining is the iron. Okay, next we have the properties. It is ductile. It is ductile because we have gone through the heat treatment process. See, heat treatment process is something which convert the hard material to soft material to hard material. So that here we converted the hard white cast iron into a softer malleable cast iron because we have some practical use of it. Okay, so as it is a softer one, it is ductile and it may be bent without breaking. Next, tensile strength is higher than grey cast iron. As it is a softer one, it have the more tensile strength. Excellent machinability, as machinability is always depend on the carbon percentage, or you can say the softness of the material. Okay, so as it is a soft, we can do various machining operations on the material. Next, good wear resistance. Okay, so as it is a harder one due to presence of carbon, it is having the good wear resistance. Okay, next we will have the applications of malleable cast iron. These are the applications you can see. This is the pipe fittings, chain host assemblies, and we can say the railroad equipments and also industrial casters, etc. These are the applications of the malleable cast iron. Okay, so these are the four types of cast iron where we have seen: the grey cast iron, white cast iron, nodular cast iron, and malleable cast iron. Please go through it with their composition, applications, and properties. Okay, the next and the last point in this lecture, we will go through the specification of cast iron. Specification means what is its name, what is its composition, what is its hardness, and the applications we can see. The first is grey cast iron. We can see here the grey cast iron. C means carbon, that is 3.4%. Si means silicon, 1.8%. And manganese, that is 0.5%. The Brinell hardness means we can say the only hardness is 260 BHN, that is Brinell hardness number. It is 260 BHN. The applications are engine, cylinder blocks, flywheels, gearbox cases, and machine tool bases. White cast iron, carbon 3.4%, silicon 0.7%, manganese 0.6%. Brinell number is 450 BHN, that is 450 Brinell hardness number, and application is bearing surfaces. Next, malleable cast iron, carbon is 2.5%, Si 1%, manganese 0.55%. The Brinell hardness number is 130 BHN. Applications are axle bearings, track wheels, automotive crankshafts. Then we have the ductile or nodular cast iron. Carbon is 3.4%, phosphorus 0.1%, manganese 0.4%, nickel 1%, and magnesium 0.606%. And the Brinell number is 170 BHN, that is Brinell hardness number. Applications are gears, camshaft, and crankshaft. See, just you remember the BHN numbers. These are always asked in the exam. Which is having the higher Brinell hardness number? Which is having the higher Brinell hardness number? It is the harder one. So you can see the white cast iron is a more harder one because it is having higher Brinell hardness number, that is 450 BHN. Then we have the grey cast iron, that is 260 BHN. Then we have the ductile cast iron, that is 170 BHN, and last one is the malleable cast iron, which is having BHN number 130 BHN. So the softer from these four are the malleable cast iron, and the harder one is the white cast iron. So simply remember the Brinell hardness number of these four cast iron. So this is a specification of cast iron. Okay. So go through the four types. Grey cast iron, white is having grey color, its application. White cast iron, white is having white color, its application. Then nodular cast iron, how it is formed, its applications. Then malleable cast iron, how it is formed, its applications, and the specification of cast iron. Go through the hardness numbers. Okay. So we will stop here. Thank you everyone. Okay.